we're going to do is to divide this section up into 2 lessons. I think there's probably too much in there for us to try to do just in one lesson, so we'll spend both today and tomorrow on it. Okay? So let's see the best way how we can proceed with this idea. Oh, suppose I took an example such as x squared minus 16 is equal to 0. And notice here we have a quadratic equation in which if we were to write down the general pattern of ax squared plus bx plus c is equal to 0, what is the value of a that we have here? What number a, Ron?
1.
A is 1, and now the value for b is what number, Brenda?
0.
Is 0. It's 0 times x, which is 0. And of course the value for c is what number? And Brenda?
16.
Is, careful now, the value of c is, this is plus c, so the value of c, Todd, is a negative 16, okay? Now, there are a number of ways in which we could solve this equation, but let's rely on our definition of square root, okay? If we were to add 16 to both sides, we'll have x squared equals 16, and now immediately from that, and using our definition of square root, what is our conclusion about x? What number x will make this sentence true? Chuck?
X equals 4.
Therefore, x is equal to 4, or x is equal to negative 4. Is that right? Right from the definition of square root. Okay, let's look at another example in which, suppose we had something such as this. X squared minus 8x plus 16 is equal to 23. Now, one thing that one is tempted to do here, I think, is to subtract the number 23 from both sides. But rather than do that, what I'd like to do is to look for a pattern. And what I'd like to do is to try to write this as some number squared is equal to 23. And does anyone see what number that we may write in here, which when squared is this expression right here? And Brenda says,
X minus 4.
here we have x minus 4. Right, is that right? All squared, which when multiplied out, let's actually multiply that out. X times x is x squared, is that right? Minus twice the product, isn't that our rule? Twice the product of the two terms in this case is what? Is 8x, and then it's this number squared, which is plus 16. Is that right? All right, now let's use the same definition that we used in example 1, in which we can conclude what? Therefore, what is our conclusion? We can say that x minus 4 is equal to what number?
23.
Not 23 now, but what we are doing is using the definition of square root, and which we can say here what? Anyone? Ken?
A equals the square root of 23.
Here we have the square root of 23, or what else can we say? X minus 4 is equal to, Ron?
23.
Not quite the number 23 now. Ken?
Negative square root.
Negative the square root of 23, okay? Again, let me refer back to the first example in which if we had x squared is equal to 16, using the definition of square root enables us to say that therefore x is equal to 4 or x is equal to negative 4. Is that right? Now, in exactly the same pattern, here we have box squared is equal to 23, therefore box is equal to the square root of 23, or box is equal to the negative square root of 23. Is that right? Where box happens to be x minus 4. Well, let's look at a third example, and I think we can see how this number x minus 4 is generated. Okay, that's really the important thing that we're now concentrating on. Suppose we were to look at a situation such as x squared, all right, let's say minus 6x is equal to 8. And in this case now, rather than again, subtracting 8 from both sides, what I'd like you to do is to look at this and ask yourself, what number can I add to the left side, which indeed I may also add to the right side, which is going to complete the square. And in fact, that's exactly what we're doing. That's the name of this procedure. And so you want to think now in terms of, say, the previous example, in which here we have x squared minus 8x plus 16. And notice now, we looked at this pattern, and we saw that it may be thought of in terms of the pattern of x minus 4 all squared. So what number do you think you would like to have here, Ron?
9.
Is the number 9. Does everyone agree with that? And if we were to add 9 to the left-hand side, of course we have to add the number 9 to the right-hand side. Is that right? Now, if we were to write this in the pattern, as we did in the previous example, how may we write this? This may be written as what, Ron?
X minus 3, the quantity
x
squared.
minus 3, the quantity squared, and of course 8 plus 9 is 17, and now we're right back to the previous pattern, okay? Now, this process that we have here is called completing the square. So in fact, let me give the name of this whole idea, this name of completing the square, okay? What we're doing here is completing the square. Now, let's continue with this example, in which again, if we have box squared is equal to 17, therefore what is our conclusion? But we can say what? And Steve?
X minus 3 is equal to square root of 17.
X minus 3 is equal to the square root of 17,
X minus 3 is equal to
or x minus 3 is equal to
negative square root.
negative the square root of 17. Is that right? All right, therefore, in fact, I think we could have come to another conclusion in example 2, so we had better come back and look at that. Therefore, what is our conclusion about x? What can we say here about the number x? X is equal to, all right, well, all we need to do here is to add 3 to both sides, and therefore x is equal to what? Anyone, Chip?
3 root
3 plus root 17, or here we have what? X is equal to, this would then read, Ron,
3 minus root
3 minus root 17, okay? And in fact, let's come back to example 2. Notice here I didn't quite finish the line in which we would like to write an equivalent sentence in which we have what? X is equal to, Brenda?
4 plus root 23.
4 plus root 23, or x is equal to 4 minus root 23. Can we add 4 in root 23 or subtract 4 in root 23? And I think you'll agree that the answer is no, so this is the most simple name for that expression. Okay? Now, here then in our third example, we have come to the conclusion that we have these two numbers which will make the original sentence true by means of this completion of the square. And what I'd like to do is to concentrate more on this idea of the completion of the square, okay? So let me do a few examples and let's see how it will go. Suppose we had something such as x squared minus 10x. And what I'd like you to do is to find some number which I'm going to add to this in order to be able to write this as some number squared, some pattern squared. And that's really what we are thinking about here in order to be able to do this. So what number am I going to add here, Barbie? The number 25. Will everyone agree with that? Okay? Because now what is our pattern over here on the right-hand side, which when this is squared, Barbie, is
X minus 5.
x minus 5, the quantity squared. Is that right? Now, let's read this sentence from right to left and see how this pattern has developed, okay? Here we have this number squared, which is x squared, minus, now since the coefficient here is just 1, isn't it? All right, it's twice the product of these two. So twice the product is negative 5x, and so twice that product is a negative 10x. And then, of course, it's going to be a negative 5 squared, which is a positive 25. Is that right? Now, let's think about the left-hand side and try to arrive at the right. Since you were talking about twice the product in order to arrive at this middle term, you see, you're looking for this number 25. In order to find it's twice that product, in order to get this number, what do you think you have to do? And does anyone have any? Brenda?
You divide by 2 and then square the root.
Divide by 2 and then square it. You have to undo whatever you did here. Is that right? In which, if you're multiplying the product by 2 in order to get the number 10, and then to undo that product by 2 is to divide by 2. Is that right? And that will then give you the number 5, which when squared is 25. Well, let's look at another example. Suppose we had something such as, suppose I wrote x squared plus 3x. And now what I want to do is to add some number, which when written in this pattern of something squared is going to be what number here? And using the pattern and the rule that Brenda just said, Chuck?
1/2
Pardon me?
would be 1/2.
1/2. Well, let's see now. Steve?
3/2.
3/2, but are you going to add the number 3/2? Brenda?
9/4.
I think it's going, well, let's write it in the pattern of 3/2, what? Squared. Is that right? It's this number squared, which is then going to be what in the pattern on the right-hand side? How may we write the pattern on the right-hand side? Todd?
X minus
X, well, in this case I have a plus, so it's going to be what? X
plus
plus
3/2.
3/2 the quantity squared. Again, let's work from the right-hand side to the left and see if indeed this isn't true. And here we have x squared, which is over here, plus twice the product. Now what is the product? The product is 3/2 x, and twice 3/2 is 3, and sure enough, there is our number 3x, plus this number squared, which is 3/2 squared, which would indeed be the number, what? 9/4. Is that right? Now, let's then take another example. Suppose I had x squared plus bx. All right? Now, if it were plus bx, again, what number should I add here, which is then going to give us a perfect square? How then are we going to complete the square, Ron?
1/2 b squared.
All right, 1/2 b squared. If you don't mind, let me write it as b over 2, the quantity squared. Is that right? Okay, everyone agree with that? So that on the right-hand side, our pattern is going to be, Ron,
X plus
x plus
b over 2.
b over 2, the quantity squared. Is that right? Again, let's square this out to make sure that we end up with the left-hand side. Here it is x squared, which is here, plus twice the product, and the product is b over 2 times x, and twice b over 2 is bx, and sure enough, there it is, plus this number squared, which is b over 2, the quantity squared. Is that right? Okay. Well, let's look at a last example here, and I think this is going to generate the pattern that I would like us to look at. Suppose we had b over a x, all right, plus some number is then going to be something in this completed square pattern. So what number am I going to add to b over a? And, well, what number are we going to add to both sides here in order to be able to make this sentence true? Ron?
b over 2a squared.
b over 2a, the quantity squared. Is that right? Okay. Such that on the right-hand side, our pattern is going to be, Ron,
x plus
b over 2a,
b over
the entire expression squared. Is that right? Okay, because when you multiply this out, you get x squared, here it is, plus twice the product, and the product is b over 2a times x, and twice that is b over a times x, and sure enough, here it is, plus b over 2a, the quantity squared. Okay? Well, it's this notion of the completion of the square that's going to be very important in the next idea that I want to do, and that's the reason why I concentrated so much on it. Now, let's look at this next idea. Suppose we had an equation of the pattern, suppose the pattern were 3x squared plus 11x plus 5 is equal to 0. Okay? And now what we want to do is to solve this equation. We want to find the number or numbers for x which will make this sentence true. Okay? What I'd like to do, if I may, is to come over here and write a pattern which is in the general case, in which we know that the general case is ax squared plus bx plus c is equal to 0, where of course a cannot be equal to the number 0. Is that right? Okay? Now what I'd like to do is to jump back and forth between example 1 and example 2, and whatever we do here, we can also do there. Okay? And that's going to be our general case, and here's a specific example. Well, the first thing that we would like to do is to get rid of this coefficient of 3. That is, we'd like to have this coefficient of x squared to be the number 1. So immediately, what can we do to the left, to this equation on the left here, Chuck?
Divide by 3.
Divide by 3. So that gives us x squared plus 11/3 x plus 5/3 is equal to 0. Is that right? Okay. Well, let's now come over to our general case. And again, right here, we'd like this coefficient to be 1. So Sally says,
divide by a
all right, which is what? Here we have what? X squared
plus bx over a
plus b. Let me write it as b over a times x plus
c over a.
c over a is equal to 0. Everyone agree? Okay. Let's now come back over here to this case in which you say to yourself, well, I'd like to have it simply of the pattern x squared plus 11 over 3 times x is equal to something. And now, so you say, well, let's just subtract 5/3 from both sides. Is that right? So it's equal to what? A negative 5/3. Okay? Let's then come over here to our general case in which you say to yourself, well, let's do what to both sides here, Bob?
Divide by C
Well, we don't want to divide by c over a, but rather, David,
Subtract.
let's subtract. Okay? So we have x squared plus b over ax is equal to, and Bob?
the opposite of C over A.
The opposite of c over a. Very good. All right, now let's then come back here to our specific case in which, notice now, right here, we want to look at this expression and we want to complete that square. So what number would you like to add in order to make this into a perfect square? And that was the object of what we did in idea A, under part A. What number now are we going to add here? And just by looking at it, you look at 11/3, and what then is the number which you were going to add, Brenda?
11/6 all squared.
11/6, it's a half of 11/3, which is 11/6, isn't that right? Squared. And so if you're going to add that number to the left-hand side, we have to add that same number to the right-hand side. Okay? Well, let's now come over here to our general case, and here we have x squared plus b over ax plus, now what number must we add here in order to make this into a perfect square? We want to complete the square. David?
B over 2A.
b over 2a,
Equals.
careful now, this is all
Quantity squared.
the quantity squared. All right, so then we'd like to add that same number to the right-hand side. So here's the opposite of c over a plus, and now let's write that as b over 2a, the quantity squared. Okay? Well, let's now come back here to our specific case, and another sentence which we may write for the left-hand side is something squared. Now what then is this something that we'd like to write in here? And just by looking at it, Steve?
X plus 11 over 6.
X plus 11 over 6, the quantity squared, which again, if you think in terms of this expression squared, let's see if indeed we don't get the previous line here, all right? There's an x squared, which is certainly there, plus twice the product, and twice 11/6 is what? 11/3 x, and there it is, plus this number squared, which I represented by 11 over 6, the quantity squared. On the right-hand side, let's simplify this somewhat, in which 11 squared, of course, is the number, what? 21 over 6 squared, which is 36, and let's write this as minus. Let's keep this as simply minus 5/3, okay? So that on the right-hand side, let's do the same thing. And what then is a name for this expression squared? What now are we going to put inside our parentheses, Chuck? X plus
B over 2A.
b over 2a, the quantity squared. Does everyone agree with that? Okay, because when we square this out, we get what? X squared plus twice the product is then going to give us b over a times x plus this number squared. Okay? Now on the right-hand side, let's again rewrite this somewhat. And b over 2a, the quantity squared, has another name of what? Let's write that as what?
B
b squared over 4a squared minus, let's just write c over a. Okay? Well, let's now come back here to our numerical case, and let's try to simplify the right-hand side. We'll leave this in this pattern. We'd like this to be equal to one number. And what then is the least common denominator here?
36.
And the number is 36. And 3 times what number is 36? 12. So 12 times 5 is 60, and 121 minus 60 is 61. All right, so now we have 61/36. Well, let's come over to our general case, in which we will do the same thing. X plus b over 2a, the quantity squared, is equal to, what's our least common denominator? 4a squared. So in the numerator we have b squared minus, now a times what number is 4a squared? 4a times c is 4ac. Okay? Let's now come back here to our particular case, and now notice we are set up in the pattern that we would like. Box squared is equal to this number, and therefore using our definition of square root, we have x plus 11 over 6 is equal to what number? The square root of 61, and in fact the square root of 36 we know is 6. All right? Or, what else is our conclusion? That our definition tells us x plus 11 over 6 is equal to what? Negative the square root of 61 all over 6. Okay? Well, let's then come over to our general case and do exactly the same thing. Our definition tells us that we have here x plus b over 2a is equal to what? Well, it's the positive square root of what expression? We have what? B squared minus 4ac, and now the square root of 4a squared, that's a perfect square, so it's outside the radical, which is 2a. Or, now we may have what? X plus b over 2a is equal to, and Sally says,
Negative square root of b squared minus 4ac over 2a.
very good. Negative the square root of b squared minus 4ac all over 2a. Okay? Let's then come back here to our specific case, and now we would like to solve for x, and so you say, well, let's then subtract 11/6 from both sides, and that's what? Negative 11/6 plus the square root of 61 over 6, or here we have x is equal to negative 11/6 minus the square root of 61 all over 6. Is that right? Okay. Let's then come over here to our general case, and now what then can we do to both sides but to subtract what? B over A. Therefore, x is equal to, and let's write this expression first, which is what? Negative B over 2A plus what? The square root of B squared minus 4AC all over 2A, or x is equal to, and what may we write here? The opposite of B over 2A minus the square root of B squared minus 4AC all over 2A. And now, coming back here to our specific example, notice the same denominator is 6, though we may write it as what? X is equal to, let's put it all over one denominator of 6, which is what number in the numerator? Negative 11 plus the square root of 61. Okay? Or x is equal to, now notice here also it's the same denominator of 6, so what's in the numerator? Negative 11 minus root 61. Okay? Now, let's look at our general case, in which we then have the same common denominator, which is 2a. So it's all over 2a, and what's in the numerator here? Here we have the opposite of b plus the square root of b squared minus 4ac, or x is equal to, it's all over the same denominator of 2a, and what's in the numerator? The opposite of b minus the square root of b squared minus 4ac. Okay? Now, here we have our two sentences, our two values of x, which is in the general case, and in fact over here we have our two values of x, which is in the specific case. Now let's actually write this using our set notation. If it said find all of the roots of this equation, I think you would agree that one of the roots is negative 11 plus root 61 over 6, and the other root is what number? Negative 11 minus the square root of 61 all over 6. Okay? Now, in our general case then, we may write a solution set over the set of all real numbers as what are the elements of this set? And the first element is right here, which is what? The opposite of b plus the square root of b squared minus 4ac all over 2a, comma, and the other element is the opposite of b minus the square root of b squared minus 4ac all over 2a. Okay? By the way, let's look at this, and remember now, the number under the radical here must be a, what kind of number in order to make this a real number? In order to make all of this element here a real number, what must hold true about b squared minus 4ac? Brenda? It must be non-negative, okay? And then also here, this number must be non-negative. And in fact, all of the cases that we will consider will probably be non-negative. Well, suppose it were not non-negative. Suppose it were negative. And what then is your conclusion? What would you have to say about the solution set to the original sentence, Brenda?
It is null in relationship to real numbers.
All right, and so therefore, with respect to the original set that you would have, your conclusion about the solution set is that it is the what? The empty set. Very good, it would be the empty set. There's another way in which some people write this, which I think is worth our doing. And let's write this in a somewhat of a compact format. I'm coming back to this line here and sort of compressing the two into one sentence, into one statement, in which some people write it as negative 11 plus or minus the square root of 61 all over 6, okay? In which it's x is equal to this, or x is equal to this, is then compressed into one, in which this plus and the minus, notice that's the only difference, is then combined into the one symbol. But when you get into the habit of writing this, you want to always appreciate the fact that you have two sentences there, and therefore you have two elements in your solution set, okay? And of course we may do the same thing here in our general case. We then may write x is equal to the opposite of b plus or minus the square root of b squared minus 4ac all over 2a. Now, this expression as written here, or else as written in this format here, is given a special name. And it's a very famous expression in mathematics. You can look in any kind of a textbook throughout the whole world, whether it be in Russian or in Chinese or anything else, and you will see this expression. And it is called the quadratic formula. All right? So let's indeed come over here and give that the heading name to this idea, in which we have here the quadratic formula. Okay? And now notice, in every case that we have here, in this specific case, we went through the completion of the square method in order to be able to arrive at our roots. Now, in this case then, suppose we did this in this example, then we did it in the second example, and then a third example, and then finally, I think you would say to yourself, well, why not do it just once in the general case, and then use that result in every example. Is that right? You think we could do that? Okay? So, what we might do then is to look at a third example in which suppose I then asked you to solve the sentence 2x squared minus 7x is equal to negative 4. Okay? Now we could go through the entire procedure as we did over here in example 1. That is, complete the square and go through every one of these steps in order to be able to arrive at this conclusion. But why do that every time? Why not simply take the result of our quadratic formula and substitute the values for a, b, and c in that formula and solve the formula? Okay? So let's see if indeed we can't do that. Now the general case, as we know, is what? Ax squared, what else is the general case? Plus bx plus c is equal to 0. Now notice on the right hand side it's equal to 0. So let's then look at this specific case and write it in the general case in the format, the pattern of the general case, which is what? 2x squared minus 7x. And now what then are we going to do to the number? Add 4 to both sides in order to give us equal to 0. Is that right? Now I think it's a good idea for us to indicate what the values of a, b, and c are. What's a equal to in this case? 2. A is equal to 2. B is equal to negative 7. Does everybody appreciate that this is 2x squared plus a negative 7x plus 4? Is that right? So this is negative 7, and c is equal to 4. All right? Now, immediately I'm going to write down this quadratic formula. And this is a statement. It's probably the one thing in the whole year's work that you have to know. There's just no way out. You have to know it. It's the opposite of b plus or minus the square root of b squared minus 4ac all over 2a. Okay? Now let's just make our substitutions. Here we have the opposite of b. What's the name for b? The name for b here is what? Negative 7 plus or minus the square root of b squared, which is what? Negative 7 squared minus 4 times a. What's the name for a? 2 times c, which is 4. Okay? And this is all divided by 2 times a, where a is 2. Okay? Let's just keep going here. And now the opposite of negative 7 is 7 plus or minus the square root of negative 7 squared is 49 minus 4 times 4 times 2 is 32, all over 2 times 2 is 4. So this then is equal to 7 plus or minus the square root of 49 minus 32 is 17, all over 4. And in fact, this is our conclusion. Our roots are 7 plus root 17 over 4. All right, in fact, let's write it as a solution set of 7 plus the square root of 17 over 4, comma, and what then is the other root? And 7 minus the square root of 17 all over 4, and there's our solution set. Okay? Now, what I'd like you to do for homework in the assignment that I'm going to give you is to do problems 1, 3, 5, and 7 by the completion of the square, by actually putting in all of the steps as we did there in example 1 under B. Okay? And then, after that, just use the formula. And I think that this is then going to give you a good experience with respect to the completion of the square. And then after you know how to do that quite well, then in fact you can just use the formula every time. Okay? So let me then give you your assignment for next time.